this block is kept on a horizontal surface. This is the horizontal surface and this is the block. So behind the block I have also drawn the skeleton in order to show the initial position of the block. Let us say this is the skeleton, which was the initial position of the block, and herein the block is kept. Alright, so now let us understand, if we apply a force on this block, let us say F force is applied on this block. So this is the force F, and this force F is applied at a certain height h, let us say from the bottom. So let's say this height is h. Now this force will have tendencies to do two things. Let us say the coefficient of friction is mu over here. That there will be two tendencies because of this force. Tendency number one is to try to translate this particular block towards the right hand side. So translation is going to take place if force is going to be greater than mu mg. Mu mg happens to be the frictional force. So if force is greater than mu mg, then the block will start moving towards the right and undergo translatory motion. So the block will move like this basically. Now let us say if the force F were to cause a rotational toppling of the block, then toppling will happen about this point. Let us say no sliding happens. So this what we have written over here is the condition for sliding. Let us assume that sliding does not happen, and let us assume that only toppling were to happen. Then in that case the analysis follows like so. This is the force of gravity mg. Let us say B is the base width of this block. Then this much part is going to be equal to B by 2, and mg into B by 2 is the counterclockwise torque. Mg into B by 2 is the counterclockwise torque about the point P. About this point, mg into B by 2 happens to be the counterclockwise torque. Now about the point P, force into perpendicular distance, height. This is the force and this perpendicular distance is the height, happens to be the clockwise torque. So the clockwise torque that is being applied is force into height h. Now if clockwise torque dominates the counterclockwise torque, then the object is going to rotate and topple like this, like so. Let us say this kind of toppling will happen about the point P. So this is how the object will tend to rotate and topple about the point P. Alright, so this motion will happen about the point P. Okay, so essentially this will happen when FH is greater than mg into B by 2. That means F is greater than mg into B upon 2h. So this particular condition is the condition for toppling. Now we can do a case by case analysis essentially. Let me get rid of these equations over here and make space for our analysis. If we do a case by case analysis, let us assume that mu is greater than B upon 2h. So there is a lot of friction present. So basically more tendency would be to topple in such a case. And if mu is less than B upon 2h, then less friction is present, then more tendency would be to slide in such a case. Now in either of these cases, let us say these are the two cases that can be present. In either of these two cases, it depends upon the force F, what exactly is going to transpire or what exactly is going to happen. Now let us say the force F the force F is greater than mu mg as well as it is greater than mg into b upon 2h. Let's say the force F is greater than mu mg as well as the force F is greater than mg into b by 2h. Then in that case, the force F is defeating the toppling condition as well as the sliding condition. So both the things will happen, but since mu is greater than b upon 2h, it will be more of toppling. So this toppling will get defeated even more basically than sliding is getting defeated. So it will be more of toppling and less of sliding if force is greater than both of them. Now another case can be mu mg is greater than force is greater than mg into b upon 2h. In such a case, sliding will not happen because force has not overcome friction force yet, but only toppling will happen. Similarly, and if force is less than both these values, then neither sliding nor toppling will happen essentially. That is understood, that I am not noting it down over here. Now if force is greater than mu mg, here also similar condition is there, as well as force is greater than b upon 2h, then both sliding and toppling both will occur. However, here since mu is less, more tendency would be to slide rather than to topple basically, unlike the first case wherein more tendency was to topple, not slide, because mu was greater in the first case. And the second possibility is that b upon 2h into mg is greater than force is greater than mu mg. In such a case, only sliding will happen and no toppling will happen. So this is the conclusion that we can draw. Another important analysis or another smart thinking or smart logical understanding of physics can be done using this particular situation. Whenever we want that the object should not topple, what we would rather do is make the height of the object very less, as less as possible. Let us say we don't want the object to get toppled. So this is an object. This object is relatively tall, so it is easy to topple it. Let us say if I am shrinking the height of the object and making it flatter, okay, then it is more difficult to topple a flatter object. Why? Simply because for a flatter object, the height h has a limitation. We cannot increase the torque about the toppling point beyond a certain particular height, because this height h itself is limited. So even if we do apply a force at the highest possible level, still there is a limit on the torque. So in order to make the object less prone to toppling, it from day-to-day understanding also and intuition also we can very easily understand that tall objects can topple very easily compared to flat objects. This is also the reason why racing cars that are F1 formula cars are made very flat, so that as they are traversing a curve, the centrifugal force is not able to topple them. And as opposed to that, the trucks and containers that are very tall, that move very slowly on intercity expressways, have to move very slowly, because if they are negotiating a turn that is a slightly narrow turn of lesser radius, then the centrifugal force may cause toppling, so they have to move very slowly. So that's the reason why flat objects don't topple very easily and tall objects topple relatively easily. So this is another conclusion that we can draw from this present analysis.